Hello everyone, welcome to Lock and Key. I hope you are doing well. Today I am back with this part 3 of set theory. Here in this video, I'll explain some exercises related to the concept of sets which I have discussed in my earlier videos. The exercises will be based on the concept of sets, tabular and set builder form, empty set, finite infinite set, equality of sets, equivalent sets. So let's start. Our first question is, which of the following are sets? Justify your answer. In my earlier classes, I have already explained the definition of set. I hope you will be able to understand and differentiate the collection between which are sets and which are not. Okay? So our first exercise is collection of all beautiful girls in a college. Now, in this case, if we'll consider this example, you can easily say that the answer will be no. Why so? Because the term beautiful is not well defined here. In our definition of set, we have come across that we have to make a collection which is of well-defined objects, right? So here the term beautiful is not well defined, and just because of this reason we cannot consider this collection as a set, right students? Next exercise, collection of all natural numbers less than 100. Obviously the collection is a set because the elements are distinct and well defined. Next, the collection of difficult book problems in a book. Okay, so here this collection is not a set. Why so? The reason is very simple, because the term difficult is not well defined. Why? Let us suppose for me some of the problems in this book, in a book we consider, is difficult. But you may say that these problems are very easy. For you these are easy, but for me these are difficult. What happening here? What's happening here? Here the term difficult is varying from person to person, right? So here the word difficult is not well defined, and because of this reason we say that this collection is not a set. Okay students, next, the collection of all odd integers. Obviously collection of all odd integers is a set, right students? Okay, I hope the concept is clear. Next question is, write the following sets in the tabular form. Here we are given with some sets which are in the set builder form, right? And we have to write those sets in the tabular form. Our task is to write these sets in tabular form. First question is x such that x is equals to n by n plus 1, where n is what? N is a natural number less than 7. This form, we all know this form is a set builder form. And what is our task? We are asked to write this set in the tabular form. Right students? Next question is x such that x is a letter in the word trigonometry. Next, x such that x is an integer and x lies between minus 3 by 2 to 9 by 2, right? And fourth exercise is x such that x is a month of a year containing 30 days. So here are the solution. Let us consider the first exercise where x is nothing but n by n plus 1, and n is a natural number less than 7. The answer is given as half, 3, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7. Now let me explain this answer. Now here, if we will put the values of n as the natural number less than 7, we will get this answer. Now we all know that which are the natural numbers less than 7. These are 1, 2, 3, 4, 5 and 6. There are 6 natural numbers which are less than 7. Now if we will put the values of n as 1, 2, 3, 4, 5 and 6 one after another, then we will get the 6 values or the 6 elements of our set, right? So let us put the first one as is equals to 1. So 1 by 1 plus 1 is equals to half. Then n is equals to 2. That is 2 by 2 plus 1 is equals to 2 by 3, which is our second element of the set, right students? So if we will go on putting these values of the n, we will get the 6 elements of the set. Is it clear students? Next, x such that x is a letter in the word trigonometry. Now you can see I have written t, comma r, comma I, g, comma o, comma n, m, comma e, comma y. Now you may ask, or you have noticed that in the word trigonometry, on the letters t, r, o, these are repeated, right? But in the tabular form, I have written only one time those letters like T, R, O, and N. Why so? The answer is very simple because as we know from the definition of set, the set should contain distinct number of elements and distinct elements. Now, if one letter is repeated, that means we should not write it twice or thrice or the number of times it is being repeated, right? We have to write only the one time, right? That letter should be written only one time, right? So I think it's clear. So the second solution is clear. Next, third one, x such that x is an integer and x lies between minus 3 by 2 and 9 by 2. Now we have to understand that x are what? These are integers and which are lying between minus 3 by 2 and 9 by 2. Now if we will put the value minus 3 by 2, after that what we can write? Minus 2 by 2. Now minus 2 by 2, if we will simplify this one, we will get minus 1, right students? Next, minus 1 by 2. Now minus 1 by 2, since this is not an integer, so we cannot consider this. We have to ignore this one. Okay. So our first term we get minus 1. Then next term minus half, we cannot consider it. So we have ignored it. Next is 0 by 2. So 0 by 2 is what? 0. 0 is an integer. Yes, we can consider or we can include this in our set. So our second term, second element of the set is 0. Next, um, 1 by 2. Again 1 by 2, that means half is not an integer, so we cannot consider this one. We have to left this one. Next 2 by 2, which is equals to 1. So our third term is 1. And then 3 by 2. So 3 by 2 we cannot put just because this is not an integer. So again we will move to 4 by 2. 4 by 2 is what? 2. So 2 we have included. This is our fourth element of the set. Then 5 by 2. Again we will ignore this one. Then 6 by 2, which is equals to 3. So our fifth term of the set. And then 7 by 2 we cannot consider. Then 8 by 2 is equals to 4. So we have taken this one. So we have got how many integers? There are 6 integers lying between minus 3 by 2 and 9 by 2. So this is the tabular form or tabular form representation of the set, which is there in question number 3, right? Next, the fourth one, x such that x is a month of a year containing 30 days. Very simple. I don't think I have to explain this one. Still, I will explain it. Month which are having 30 days in a year. There are only 4 months: April, June, September, November, right students? So these are the elements of the set. I hope this is clear. Next, write the following sets in the set builder form. What we have done in our earlier question, just opposite we have to do it. Like earlier we are given with the set builder form, we are asked to write in the tabular form. Now we are given with the tabular form, and our task is to convert those tabular form into set builder form, right students? So these are the questions. First is 1 comma 0, second is minus 1 comma 1, then the set containing 14, 21, 28, 35, 42 comma dot dot 98, and fourth one is BENGI. These are the questions. Now the solution part. So first one, 1 comma 0. What I have written in the solution? X such that x is a digit in the number 10. Obviously we know in the number 10 what are the digits there. there are only two digits, 1 comma 0. So obviously you can understand that we have written it in a set builder form. Next is minus 1 comma 1. Now I have written x such that x is the root of the equation x square is equals to 1. Okay, so you all know, or we all know, that x square is equals to 1 contains the root as minus 1 and 1. So I have written just that one only. Okay. Next, 14, comma 21, comma 28, comma 35. Okay, so this is particularly following a pattern, right, students? And these all are multiples of which number? 7, right? And here starting from 14, 2 digit, okay, and ending with 98, 2 digit, means these are within 100, right? And what I have written in my answer solution, x such that x is a multiple of 7 lying between 10 and 100. Is it true? Yes, it is the answer, that these are the multiples of 7 and these are lying between 10 and 100, right, student? So it's clear now. Now next question is BENGI. Now in any case, if you are finding such kind of questions, the first thing should come to your mind is you have to find, you have to just find the word which can be formed using the given letters, right, students? So here in this case, which word can be formed with these letters? Begin, right, students? So we can write in the set builder form x such that x is a letter in the word begin, right? So here are the solution. I hope this is clear for you. Next question. This question is based on the empty set. Now, which of the following is the empty set? Here I have given 4 exercises where you have to find out which of these 4 sets are empty set, right? So first one, x such that x is a real number, neither rational nor irrational. Now in the very first class I have already explained or have given a uh, mm, chart of real numbers where I have distributed the real numbers in many different types of numbers which are the sets. Okay, so please go through that to get clear vision or clear idea of this concept. Again, let me repeat it. Real number can be either rational or irrational, right, students? So there should not be any, there is no number which is not a real number or not a rational number or an irrational number. And there is no such real number which is neither a rational number nor an irrational number. That means what? That only means that our set capital X is an empty set, right, students? So X, yes, in the solution part I have written X, that is x is an empty set. Now y, if we will consider the equation 2, that is y is equals to x such that x is a non-zero real number satisfying x plus a is equals to a for every real a. Now please tell me, is there any real number which can satisfy this condition? I hope your answer is no, right? So no need to worry. If your answer is no, that means the set is an empty one. It's an empty set, right, student? So y is an empty set. Next, z. Z is what? X such that x is a vowel in the word day. Now please tell me, in the word day, is there any vowel? Yes, the vowel is a. So if we are getting a vowel, that is a, in the set, that means we are getting an element. And that means this set Z is not an empty one. So this will not be an empty set, right, students? Next question. T is equals to x such that x is a point common to two given parallel lines. Now come back to go back to class 10 geometry. Now tell me, if you are given with two parallel lines and you are asked to find one common point, will you be able to find it? The answer is no. So, no need to worry. If your answer is no, that means simple. Your set T is an empty set, right, students? Isn't it interesting? Yes. So, these are the questions I have collected for the empty set. Next. Which of the following sets are infinite? Now, just for our knowledge, I want to revise the definition of finite and infinite set. Now, which are finite sets? Finite sets are nothing um, but if the process of counting of different elements of a set comes to an end, that set will be known as a finite set. If it doesn't happen, that means the set is an infinite one, right student? So in this question, we are asked to find which are the sets which are infinite. We are given with some three sets and we have to find out which are among this three which are infinite, right? So first one, p is equals to x such that x is a natural number less than 1 million. Okay, so first question, and for p, that means that p is obviously a finite one, because from the definition or the from the representation of the set, it is clear that we are comes to an end, that is the number, natural number less than 1 million, so obviously it will be a finite one. Next question, q is equals to x such that x is a line parallel to a given line. Okay, again back to the class 10 geometry. If you are asked to if you are given with a line and you are asked to find the parallel line to that given line, how many lines you will be able to draw? Tell me. Yes, the answer is infinite. So if you are getting infinite number of parallel lines to a given line, so obviously your set will be an infinite one, right students? Next, r is equals to x such that x is a sphere passing through a given point. Okay, it is also a simple and just the revision of class 10 geometry concept. If you are given a point and you are asked to find the sphere, number of sphere passing through that particular point, what will be your answer? Obviously you will be getting infinite number of sphere passing through that particular point, right? So if you are getting infinite number of sphere passing to that particular point, that means your set R will be an infinite set, right students? So the infinite sets are Q and R. P is an finite set. I hope the concept is clear. Next, which of the following sets are equal? Now, we all know what is the definition of equal sets. Two sets are, say, suppose A and B are said to be equal if and only if every member of A is a member of B and every member of B is a member of A. Simple, isn't it? So we have to just find out the equal sets. So here I have given 1 2 3 4 5 6, yeah, 6 number of sets and we have to find the equal sets. So for that, um, can you do it? I know you can do it, but I will do one set for you and another set you will be doing by yourself, right? Why? Because there are two sets, the solution, as the solution says. So A is equals to B is equals to E. I'll do it for you and the next one you will do it by yourself, right students? So first, A is equals to x such that x belongs to set of natural numbers where x is less than 4. Simple. Natural numbers less than 4, 1 2 3. So set A will be containing the elements 1 comma 2 comma 3. B is what? 1 comma 1 comma 2 comma 3 comma 3. Here 1 and 3 is repeated, right? So we can rewrite this set capital B as 1 comma 2 comma 3. So what we get? A is equals to capital A, set capital A is equals to 1 comma 2 comma 3, capital B is equals to 1 comma 2 comma 3, and E is given as 1 comma 2 comma 3. So obviously from the representation it is clear that all the elements of set A are the elements in the set B and vice versa. Same implied to B and E and A. So A is equals to B is equals to V. So these are the equal sets. Now if you will consider C, D and F, you will get the same. You can do it by yourself. I know it, right? So do it. Next, equivalent sets. Now, select pairs of equivalent sets from the following sets. Here I have given again 6 sets, and you have to find the pair of equivalent sets. Now let us revise the definition of equivalent sets as well. Two sets, any finite two sets, are said to be equivalent if the number of elements in both the sets are equal, right? So what is our task? We have to find the number of elements in the this 6 sets, right? So first one, a is equals to x such that x is a vowel in the English alphabet. Now come on, first tell me how many vowels are there in English alphabet. KG students can answer this one. It's 5, right? So number of elements in the set capital A will be 5. Next, if we will consider that set C, what we will get, x such that x is an even positive integer less than 11. Now come on, first tell me what are the even positive integer less than 11. It's 2, 4, 6, 8, 10. How many integers? 5. So number of elements in the set C is 5. Now if we will consider this A and C, number of elements in both these sets is 5. So obviously this A and C will be equivalent sets, right? Now if you will check for B and E, these will also be a pair of equivalent set. And if you will consider D and F, again you will see that D and F will be a pair of equivalent set. Now do it by yourself. Okay students, I hope you have enjoyed this one. Next, this question is based on the concept of empty set. Here I have given 6 statements. Okay, you have to find which are true and which are false. Now as soon as we got listen the word empty set, we all know that empty set can be represented or denoted by the symbol phi, right? Here the concept or the idea of phi is represented or get cleared using these statements. Okay, so let us see how. First, phi belongs to set empty set. Now is it true? The answer will be false. Why so? Because empty set itself represented by phi. So phi cannot be there in empty set. Empty set itself is phi. So this statement is completely false. Next, question 2. 0 belongs to the set containing phi. Obviously there is no 0. So obviously the statement is a false one. Third, phi belongs to the set containing phi. Yes, phi is there in the set containing phi. So obviously this will be a true one. Next, 4. 0 does not belongs to the empty set. Obviously, is there any 0 in the empty set? No, there is no element. So obviously this statement is a true one. Next, 5. 0 belongs to the set which contain the set 0. Is it true? No, because here the set containing the element set 0. Okay, so here 0 is not an element. Here in the set you have seen that 2 braces are given, after that one 0 is put. What does it mean? This means this is a set containing a set 0. Means the element in this set is itself a set containing 0. So a single digit 0 cannot be an element of this one. Okay, so this statement is a false one. Now if you will consider the sixth exercise, that is phi belongs to the empty set of empty set. Now see, here this statement is true. Now if you can compare this exercise 1 and 6, you can see that 1 is false. Why? Because phi or the empty set itself represented by phi. So we cannot say 1 is true. 1 is definitely false. But in case of 6, we can see that phi or the empty set is there in the set. So obviously 6 is true, right? Okay, so here in this video I have tried to cover all the concepts whatever I have discussed in my earlier classes. You go through the book and try to find similar exercises, or the exercises which will be based on the concept I have already discussed in my last videos, and try to solve it. Set is a very interesting chapter, and if you will solve these exercises now, you will clear all the concepts related to this set. Okay, so my advice is go through the book and practice thoroughly the exercises related to whatever concept I have discussed till now, and try to get a control over this set, because this is really really an interesting topic. Okay students, so I hope you have enjoyed this video, and in my next class I'll try to cover some more concepts from this set theory. Till then, practice, practice and practice, as the guru mantra to learn mathematics is practice. Okay students, take care, bye bye.